All right, ladies and gentlemen. Today we're going to look at writing and interpreting a numerical expression in order to explain and model the commutative, associative, and distributive properties. Now, again, these are things that you may be familiar with from last year, but it's going to build on what we're going to talk about this week and also throughout this school year. All right, so we're going to look at the Common Core standard, which is 50A2, and that primarily deals with the order of operations. All right, and again, we're going to build on this and get into the order of operations during the week. But today, I really want to focus on the three properties that you see there. I'm going to go ahead and show you this Study Jams. It's a great website. Again, I highly recommend that you use Study Jams for math and science topics. And you will, of course, hear myself and other teachers mention that. So let me go ahead and show you the Study Jams. All right, so hopefully you're able to see it, of course. And here with Study Jams, we have properties of addition. And I'll just go ahead and read it to you, but it says addition properties are rules that you can follow when adding numbers. The commutative property, associative property, and identity or zero property are the rules. Now, in fifth grade, we don't really talk much about the identity or the zero property. Nonetheless, we talk more about the commutative, associative, and distributive property, okay? Now, they can make adding as simple as singing a song. Now, I'm not going to sing the song for you, so just act like I did. Great thing that I like with Study Jams is it gives key vocabulary terms, as you see here. So we have property, which is a special quality or characteristic of something. Associative property, which is changing the grouping of three numbers in an addition problem, does not change the sum. And an add-in, again, mathematical term, that's any number that is added to another to form a sum. The sum, of course, mathematically speaking, is the answer to an addition problem. In the equation 6 plus 4 equals 10, the add-ins are 6 and 4. The sum, of course, would be 10. Then we have commutative property, where two numbers can be added in any order. The sum will remain the same. Okay, so it can be switched around, but the answer, the sum, will, of course, be the same. And we have identity property, is when you add 0 to any number, the sum is that number. Again, we're not going to focus too much on identity, but it is still available for you to know. All right, so let's click step by step and take a look.
There are three properties of addition: commutative property, associative property, and identity property. For homework, we're supposed to pick out real-life examples of how these properties work. Check mine out. The commutative property of addition says that when you change the order of the numbers being added, the sum stays the same. For example, I wanted to upload the pics from the practice concert we had in my garage last weekend and put them in an online album. I had 6 pictures on my camera, and Mia said she had 9 on hers. If Mia sends me her 9 pictures, that'll make 15 total pictures. If I send her my 6 pictures, that'll still be a total of 15 pictures. It doesn't matter which way you order it, the sum is the same. The associative property of addition states that when you change the grouping of the numbers being added, the sum stays the same. For example, let's say I just found out Sam also took 4 pictures at the concert. We could write the equation as 6 plus 9 and then add another 4 for a total of 19 pictures. But if Sam sent me his pictures before Mia sent her pictures, we'd still have a total of 19 pictures. It doesn't matter how we group the numbers, we still get the same sum in the end. The identity property of addition, sometimes called the zero property of addition, says that when you add 0 to any number, the sum will be that number. Okay, I gotta admit, this property is pretty easy. For example, I have 19 pictures from the concert after Sam and Mia sent me their pictures. I checked with RJ to see if he had any pictures, but he had none. 19 plus 0 equals 19. That leaves me with 19, the original number. Well, that's all 3 addition properties: associative, commutative, and identity. Finding real-life examples wasn't so tough. I think we use addition all the time. We don't even realize it.
All right, so I'm gonna close it out. Okay, and let me share this one. This was, of course, on vocabulary. And if you know what vocabulary is, you might be into it. Hopefully, this is talking about distributive property or other properties. So take a look. And the list.
Commutative, associative, distributive, all 3. Math properties, yeah. Vocab, let's go. The first property is commutative. Your terms can move when you're the one computing them. If you reorder the terms when multiplying and adding, you get the same answer cause the order doesn't matter. 3 plus 5, written a different way, is 5 plus 3. They both equal 8. A plus B equals B plus A. And J times C equals C times J. Addition is not the only operation that works. We can also use multiplication, but this rule, it doesn't work with subtraction or division. With subtraction or division, stick with the order given. If you need a mnemonic, think about the root. Commutative comes from the word commute, yeah. The commutative properties, the one that allows us to write the numbers down, then move the numbers round. A commutative property in any order, you can add and multiply. Associative, you could group the terms any way you like. And now the last one, when you multiply a sum, you gotta break it up. That's distributive property, it's gotta be commutative, associative, distributive, all 3. Math properties, it's what you need. It's what you need. It's what you need. Associative property means when you compute several numbers, you can put them into groups. For example, 2 plus 5 plus 3, add parentheses so you can see. Place 2 plus 5 in parentheses and then add 3 at the end. Now let's begin. 2 plus 5 equals 7, and when we add 3 plus 7, the sum is 10. If we bracket the 2 numbers at the end, the answer's still 10. If we do it again with multiplication, it works the same way, but division and subtraction, then they can't hang. Commutative property in any order, you can add and multiply. Associative, you could group the terms any way you like. And now the last one, when you multiply a sum, you gotta break it up. That's distributive property, it's gotta be commutative, associative, distributive, all 3. Math properties, it's what you need. It's what you need. It's what you need. This property is distributive, and when you can use it, is limited, yeah. When you multiply a sum, you can multiply each adding and then add the products up. Take the problem, 2 times 5 plus 3, and the 5 plus 3 is in parentheses. You can multiply the 2 times the 5, and then multiply the 2 by the 3. Alright, you get 10 plus 6, and that's 16. We distributed the 2 here. See what I mean? Here's a nice hint to make it easy to remember. To distribute means to give it to each member. Just remember, multiply each number in the bracket by the number outside. Add them up, then you have it. 8 times B plus C equals 8 times B plus A times C. C.
All right, it's lit. Anyway, hopefully you enjoyed that. All right, so let me go back here and show you this now. Okay, hopefully it'll work. All right, so as you heard, of course, from those 2 things, from study jams as well as vocabulary, it mentioned and talked about 3 different properties, okay? One of the reasons there is a distributive property video on study jams. it was not working. So that's why I have not put it up here. But please feel free, go check out Study Jams. Google it if you need to. Studyjams.scholastic, I believe it's .com or .org. But once you type in Study Jams, you will see it pop up. And, you could search for distributive property for a better understanding of that as well. But nonetheless, let me go ahead and just show this to you, okay? Here are some basic definitions that I could go ahead and give it to everybody, and I would like you to have it. So we have the commutative property. When adding or multiplying, numbers can be switched, and the answer result will be the same. Again, the commutative property is when adding or multiplying, numbers can be switched, and the answer result will be the same. So let me write an example for you so you can see it, okay? I'm just going to put EX here, example. So that's like saying, okay, 2 plus 3 equals 5, right? I can then, of course, switch these two numbers, and I would get 3 plus 2, and I would still get the same answer, right? I know that does not mean does not equal. Again, forgive my board, okay? Just erase all of that and just put equals 5. Another way of looking at that is multiplication. Now, this also works for multiplying. 2 times 3 equals 6. And if I go ahead and reverse these two numbers, I would get 3 times 2, which also equals 6. So again, the order does not matter with commutative, okay? The answer, the result is going to be the same. Again, for addition, the answer for an addition problem is called sum. The answer to a multiplication problem is called product, okay? Please remember, as best as you can, those specific mathematical terms, okay? Next, we have associative property. Associative property, again, I just gave some simple definitions to help you understand it better. When numbers are grouped together, the order does not matter. The answer or the result will be the same. So when numbers are grouped together, the order does not matter. So again, let me do an example so I can show you, okay? An example. We have 2 plus 3 plus 5, okay? That would equal 10. And if I wanted to go ahead, again, I have 2 plus 3 plus 5, but I group these numbers, right? 3 plus 5 equals 8 plus 2 equals 10 as well, okay? So again, that works, associative. It's when numbers are grouped together, okay? Now, of course, we have the distributive property. Distributive property is when you multiply a number by a group of numbers added together, or you do each separately by multiplying, then add. So, for example, we have 3 times 2 plus 4, which can also be said as 3 times 2 plus 3 times 4. This would equal 6, and this would equal 12. And if we were to solve this problem here, right, just as is, in parentheses, 2 plus 4, and again, when we get into further this week of order of operations, you will definitely understand this better, right? You solve what is in parentheses first. So 2 plus 4 equals 6, and 6 then times 3 is 18. The same way you could say is 3 times 2 plus 3 times 4. You get 6 plus 12. That also equals 18. Okay? All right, so that, of course, wraps it up with there. I hope you have taken what you have learned today. And again, throughout this week, we will continue to build on solving these problems. All right? Thank you so much. Remember, strive for greatness.